Okay, Jenna, put that away.
Ready?
All right.
No.
You guys are good. If you wanted to see the die, I would have you step to the left.
Okay. Hi guys, my name is Branden Bedoya,
I'm very boring.
and we're going to be discussing how the advancement of technology impacts manufacturing and jobs. So for starters, at our internship, we got to design many products. As of here, we didn't finish it, but we at least attempted making this antigen processing unit, which basically takes a little cartridge, inserts it in, checks for making sure that they're all filled up, and then ejects it outward.
So here we have a product that we made. We actually 3D printed it. It is 4 to 5 separate components. And so we actually manually built this, but imagine like an assembly line of like automated machines that actually pieces it together. So obviously that would eliminate us from the manufacturing process. If you guys want to like pass it around, you can.
So for the history...
Before we went any further, what is that?
That's a phone stand.
You didn't tell us.
Yeah.
Okay, good. I don't want to wait.
Okay, so for the history of manufacturing and technology, before we start talking about the present and the future, we have to go back in time. So, beginning of the 1800s, we had the first industrial revolution, which came about with steam power. So, like the steam-powered engine, the first steam-powered trains, which really revolutionized society.
So a couple decades later, we have the second industrial revolution. The second industrial revolution included electric power, so obviously like light bulbs that we have here, and that obviously increased the production and the productivity of businesses because the lights can obviously illuminate the room even when it's at dark.
Then at the beginning of the 1970s, we had the third industrial revolution, which came about with the information technology. So computers, radios, television, all that stuff.
And then the fourth industrial revolution includes digital information. This includes big data, artificial intelligence, stuff like that.
That's what we're currently living through.
Mm-hmm.
So here's a quick visual of what we just discussed. So you had first mechanical driven machines that were water and steam powered at the beginning of the 1800s.
And then in the second industrial revolution, we have the first conveyor belt in Cincinnati slaughterhouse. That was in 1870. So then the meat can obviously go in a continuous motion, obviously batch or flow production.
Third industrial revolution, that's when we first started programming and getting robotics introduced into the workforce and manufacturing and whatnot.
And then the fourth industrial revolution is obviously today, and it's based on cyber-physical systems. And as we go along through the years, you can see the degree of complexity obviously increases as technology increases.
So here we have a
video.
Would that work on a different computer?
Maybe you hit
No.
the HDMI cable real quick when you're resting more on the computer.
Yeah, just replug it in. You'll be fine.
Yeah, take it out.
Okay, bud?
I think you take out the HMI.
Oh, there we go.
I get it.
Okay. Abe, you have a job, right? Have to be here for
If
every
you're watching this,
presentation.
you're among the 3% of people that understand that the future of work is going to look very different from what it is now. So keep watching. Let's see where we're headed. It's also exciting, right? Siri will recognize your voice even if you're 5 meters away from your phone. That new chatbot feels totally real. Self-driving cars are no longer fiction. You can analyze your DNA. You tried flying that drone for the first time, and you're thinking of buying a smart speaker to make your life so much easier. A few years from now, and that's something like 3 years, not 30, artificial intelligence, robotics, machine learning, mass 3D print, biotechnology, chatbots, virtual reality, deep learning, drones, augmented reality, smart objects will all be deeply enrooted in our everyday lives. Just like computers, phones, or electricity are for us today. Oh well, is this really gonna happen? And if it does, you'll adapt when the time comes, right? Life is good. You love your job. You've been working for this established company for a few years. You're comfortable in your position. You know what you're good at. People like you, and that last presentation you gave got you some amazing reactions. You're safe with your company. In the meantime, you see an article or two speculating on the future of jobs. McKinsey published a report stating that 45% of all current tasks could be automated with present technology. The World Economic Forum estimates that 33% of jobs in 2020 don't even exist yet. But what do they know, right? You've got time.
Okay.
Okay, so now that we just discussed the fourth industrial revolution and what's occurring, but now we want to tie this into our internship. So Branden and I interned at Endeavor Manufacturing Incorporated. So if you want to elaborate on what they are.
Oh, sure. So Endeavor Manufacturing Incorporated is a small manufacturing company. They're obviously driven by innovation. We have these like small projects. I know a couple of coworkers there, Aaron Lalunde, you guys don't know him. But basically they give us like these small projects to work on to improve the company overall. I know for one we had these bottle caps with like protein powder or something, and he just wanted like innovation, something like that. And then for another one we had I believe it was like a pump system for doctors, stuff like that. So just small projects that they would give overall.
And this right here, the antigen process. So basically before they would have this little cartridge that doctors would use to check if you had any allergies. So they had 96 of these to test you out for all the different foods and whatnot. And they would have to process this and dry it. And our task was to have a little scanner with LEDs on the top and bottom to make sure all of them are filled correctly, and to label them on the side, because all of them, like there's type A and type B, and you would put a little label on them. So that's pretty much what we did our internship.
So they also manufacture these RFID scanners. It's basically like when you swipe your credit card like through any type of like scanner. That's what RFID is pretty much.
But instead of having to swipe, you just kind of tap it.
Yeah.
It does the process for you.
We also engage in projects such as the Smart Mirror, which you'll see pictures of coming up.
Alright, so what technology AMI uses? So there's three main rooms. The machining room is in the back, where we worked there a few times. There's CNC machining metals. So it's like a very fancy drill, pretty much. It takes a block of metal and it'll cut it in whatever way that you program it to. And then there's industrial cutters, just different types of ways to fold metal, cut metal, and whatnot.
Mm-hmm. So the main floor is where obviously we 3D print. That's where that was 3D printed. We also laser cut. They also engrave I believe pieces of metal. Like they have a laser that obviously engraves. Wire cutting, crimping, and soldering. That includes like your motherboards and stuff like that, and your Arduinos.
That's putting electronics together.
Yeah.
And then third, we have the laboratory. That's where they do lab work. That's where they do airtight packaging for everything that we discussed with the antigen processing. And yeah, that's pretty much all the main floors that they have at EMI. So here's a smart mirror that we were working on with them. Basically, it's a television within a mirror, and then they sold it off to a company. They had the company logo, they had the current time, they have news, stock, they could program it to whatever people want, and then in the center it's blank, so the person can look at themselves in the mirror.
And they all program that on that. This is the Raspberry Pi right here. So then you can basically just program anything, and then it'll display on the screen.
So yeah, that was our antigen processing thing before it got damaged, but we don't talk about that. And then this is also when we were first working on the project. Some more pictures of us working in the machinery room, cutting metal and whatnot.
So issues with technological change. Obviously, we have a couple issues to address. Mass unemployment. So as technology increases, obviously the skills needed to operate these machines will enhance, and then obviously the more skilled employees will obviously survive in the marketplace. So obviously blue collar work equals less needed, where white collar jobs will increase.
There's a study by Stanford.edu, which we saw that from 1870 to 1985, the amount of jobs that were occurring grew exponentially with the first, second, and third industrial revolution. But now coming with the fourth industrial revolution, we're seeing a decrease in overall jobs, and there's new skill sets that are required.
So this new technology means that there will be a decrease in demand for low-skilled jobs.
So here we have a little picture depicting all the current jobs that are in demand. As you can see, web developers, 27% growth, computer user support specialist. So basically everything to do with computers, analytics, data, that's on the rise, while manufacturing and production processes are going down.
Anything to do with manual labor, hands-on. So new tech means new jobs and losing old ones as well. So examples of jobs being replaced.
Alright, so horse trolleys, they used to be essential for moving goods and services and people from point A to point B, but once the car came around, there was no need for it. So that's an example of a technology being replaced.
So hand shoemakers are being replaced by machinery. Obviously, this was a couple decades back. But hand shoemakers, they would obviously tailor the shoe specifically to the person. They would manufacture it and assemble it accordingly. These are being replaced by machines. Like I'm pretty sure Nike has like a mass production line of shoes.
Book writers, people used to actually have to sit down and rewrite books by hand. And once the printing press came about, there's no need for that because you can do way more books in much less time.
So milkman by grocery stores. So obviously in the past we had milkmen that would deliver your milk to your door, but now they're being replaced by grocery stores. So.
Alright, and we had evolutions. So some new jobs that are on the rise. Computer programmers. So you need to be able to develop websites, programs, applications, pretty much everything that you use, and you need somebody that has to code it and produce these software. So that's what computer programmers come in for.
So technicians, as technology increases, the amount of technicians needed to operate the machines and take care of them will increase as well.
CAD engineers. CAD stands for computer aided design. So these are engineers that come about, they design products, they iterate it, they adjust it however they need, and they can make multiple products and multiple versions of it in much less time. So it really helps in the development process.
Mechanical versus biomedical engineers. So we obviously see a increase in biomedical engineering. The growth is probably about like 15 to 20%, whereas mechanical engineering, it's 1% growth, I'm pretty sure. And then we see that mechanical deals with manual skills, so obviously assembling that. And then biomedical, you see an increase in technology in that field, so obviously there is an increase in the growth.
Alright, so productivity and cost. How does this affect overall production and the economy? So if you guys can see in the back here, that little picture of cars, this is an example of batch production because you take a car and you have to build it component by component, and it's a step-by-step process, which, robotics pretty much does the majority of the work. And then here we have a picture of Coca-Cola mass-producing millions of Cokes per day. That's an example of flow production, how, you can make tons and tons of products in a very short period of time versus having to do it by hand.
So obviously having more automated machinery means that it drives down the price and obviously replaces the manual labor required.
Alright, so quality versus quantity. Here we're just discussing how handmade items, obviously, is going to be of higher quality and more specific and tailored to the customer, while mass-produced items, they're going to be a lot cheaper, less specialized, and probably a lesser quality overall, but you have a much higher amount available, which decreases the costs.
So what is 3D printing? 3D printing is a process by which plastic or metal is heated up and then extruded through a fine tube, and this is assembled layer by layer on like a little platform. So obviously it creates 3D structures that you design, so you can rapidly prototype these with quick iterations. So you don't have to go through the process of CNC machining every specific metal and stuff like that.
Oh, sorry.
You want to
Go.
go? Okay. So here on the right side you have General Motors 3D printing. On the left right here you have a component. It's obviously, it's actually a belt buckle. So you have 8 components on the left versus 3D printed component on the right side, which it's same function, just different structure. And the 3D printed one is 40% lighter and 20% stronger.
That goes to show how effective 3D printing can be, apart from just its cost.
Okay. So rapid prototyping, how businesses can utilize 3D printing. Obviously I just explained that, quick iterations and less labor intensive, so you don't actually have to go through the process of coding. You're going to actually have to go through the process of CAD design, stuff like that.
So yeah, 3D printing overall is less labor intensive and it's a lot quicker than having to develop things by, machinery. Alright, so here's a video. Alright. So this is an example in China where they have 3D printers printing houses. So
However, technological limitations prevented the building's roofs from being printed. The buildings will serve as offices at a high-tech industrial park in Shanghai. We visited the company's workshop in Shanghai's neighboring city of Suzhou to find out precisely how the buildings were printed. The walls are primarily made out of material refined from construction waste and mixed with cement.
Alright, so what you guys just witnessed is a 3D printer printing a house. So like, yeah, this is small scale, but 3D printing can also be used at very large scales, and it can drive down costs. So 3D printing a house, according to the video that we just watched, they said it takes about 12 to 24 hours to produce one home, like a single family home, while current construction is about 13 to 20 days. So New Story predicts that the cost of producing a 3D printed home will be about $4,000, as opposed to how currently it's about $136 per square foot, while 3D printed houses are about $6 per square foot. So it's 22 times cheaper to produce a 3D printed house. So this shows how practical this can be in society overall.
So this has some significant advantages and disadvantages. Obviously, a disadvantage would be that the construction workers that obviously work on the houses, their jobs will be taken away because you have 3D printers. But for the consumer, it's significantly cheaper.
So, do all companies need to advance? So, we just witnessed how technology is revolutionizing the business world, but the question is, do all businesses need to adopt new technologies? And we came up with the conclusion that no, it depends on your niche market. For instance, 3D printing is not always needed. It just depends on the scale of your business, your overall market share, and who you're trying to tailor your products towards, and how much you're trying to produce.
And obviously it varies based on corporate objectives, so automation is not always needed, depending on the manual labor required on the lower levels.
So here's some projections. We don't have a handout with us right now, but just imagine a nice projection paper that like...
We actually had it up on the...
Yeah.
If you want to show them.
Alright, sure.
I'll show you the website.
Yeah. Alright. So imagine if this was
it's not okay.
No!
This is a disaster.
Alright, whatever.
Just make sure that you deliver the stuff that needs to be printed or ask the printers to.
Okay.
And then I will
We'll
print it
send you the
and
link.
have it, yeah.
Yeah.
Everybody heard that?
Yes.
Okay.
Okay, so imagine we handed out a paper that kind of analyzes all the different jobs that there are currently and what jobs are more likely to be replaced, while other jobs that are less likely to be replaced, and what technologies are going to become obsolete. So you guys can see from this little graph here, it shows jobs like cloud computing, mobile services, Internet of Things, bioengineering. So a lot of these like higher order jobs are going to be increasing, while like manufacturing and lower skill jobs are going to be decreasing overall.
And we can see at the bottom that it's man-machine hybrids. So anything that has to do with like interacting with a robot or manual labor will obviously be less growth in the future compared to cloud computing services.
So, quick question for you guys. What skills do you think are required in the new economy and the new business force, in the workforce? Anyone? Yeah?
Being able to interact with artificial intelligence.
Okay. Anyone else?
A good form of computer skills and like just good computer skills and like know how to
Okay.
Anybody else?
I think Mr. Wu has something.
Me?
Yeah.
Critical thinking.
Is that always?
Mm-mm.
Okay. So here's what we found according to the World Economic Forum. This is showing the top 10 skills in 2015 versus the top 10 skills in 2020. Skills like complex problem solving, they're still going to be like required in the years to come. Creativity is going to be increasing. The overall ability to have emotional intelligence. So
anything that has to do with human interactions, pretty much, over repetitive processes, because repetitive processes can obviously be automated. Social workers, for example, like psychologists, can't be replaced as easily as like anything that requires like hand labor.
yes. So pretty much any repetitive processes are more likely to be replaced, while jobs that require more human interaction and cognition are going to be still in demand.
Critical thinking is number 2.
But, okay, go ahead.
Yeah. All right, so some technology amongst countries. So China, I'm sure you guys all hear about China and everything that they're always on the news for. They have a huge population and they're very labor intensive, but currently they're moving away from the manual manufacturing processes that you usually see like there. Now they're having new technology and infrastructure, which is why new countries like Panama are the go-to places for countries like the U.S. to outsource to, just because the living standards of China are increasing, so they have to move to other places, or they have to use robotics. So it's either you have a cheap labor force or a very advanced labor force.
So USA, as Bedoya just mentioned, obviously they outsource to different countries, but internally they have advanced significantly, or we have advanced significantly. We have advanced manufacturing with robotics. So as you can see right here, you have Elon Musk within his Gigafactory. And what these Gigafactories do is they obviously mass produce car batteries for their Tesla cars. And then high intelligence jobs with training and education. So obviously higher forms of education will be required to operate within these facilities.
All right, so what type of manufacturing is used in different countries? So MDCs, or more developed countries, they're going to be using more robotics, and they're going to require high-skilled workers like in the U.S., South Korea, and whatnot. While less developed countries are going to have a high quantity amount of workers. They're going to be more low-skilled, so they're going to be doing very repetitive jobs.
So they're basically going to get the outsourced work that the more developed countries obviously want to outsource to them.
All right, so what's the impact on all of this? So technological changes that we have seen over the years from the 1800s until now drives economic changes, and economic changes are going to drive social changes. So as the economy changes due to technology, societal norms of education will be changing.
And we have a video on that?
Yes.
Like, you know how in like normal schools you have the rows of desks. Like, hopefully in the future we can make it more interactive with these goggles, I believe. I don't know, Microsoft has them, and you can make it more interactive in the environment instead of having like a manufacturing line.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see.
Okay, so that was a ad by Microsoft. They released it in 2015, and it was pretty much like showing their new technology and how they can integrate like augmented reality with like, you know, as you guys see, pretty much everything. We tied it into learning because you know, if you guys think like to the past where you would have like the old school projectors when you would write on the little you know, old light bulb, and now we have like regular projectors, and then in the future we could have a teacher with the HoloLens along with all the students, and they could all like interact with whatever they're trying to teach.
So solutions, obviously the question that everyone's hopefully asking is, what will unemployed people do? What will be of your future? So have a potential solution is have global governments encourage higher level education. Obviously these forms of education will be irreplaceable by AI and robotics, and try to major in something that, or try to look forward in time and predict what types of jobs won't be replaced by AI.
So we're getting like traderships, certifications, 4-year degrees and whatnot. This will all help with aiding against unemployment. And then there's also the solution, or at least proposed solution, of a universal basic income, which pretty much says for everybody that gets unemployed, the governments are gonna give you enough money to sustain yourself and live off of. But the question is, how are we going to fund this? Proposed solution that we thought of was being able to tax machinery per unit created. So if an automated machine, you know, makes X amount of products, while like a person would only make like a minimal amount of products, for every like batch created by the machine, which, you know, is obviously greater than what the human would make, they can now tax that and then fund the universal basic income.
So summation, obviously. Automation, you're obviously going to, it's a potential to gain new jobs and lose old jobs, manual labor. New solutions to issues arise in the potential future, and it's overall more productive, but how we deal with unemployment is the ultimate question with the solutions we obviously just introduced before. And obviously this increases the standard of living, because when you have 3D printed houses that drive the overall cost down, you won't have to spend so much money into an apartment or like a house when you could buy the $4,000 house versus a house that's, you know, an insane amount. So, a question? No?
Nobody has any questions about your future? Okay.
So taxing machinery, don't you think that tax would just be passed on to the consumer in the product?
Yeah.
If the companies, I mean, the government collects the tax, but
Right.
the tax actually now becomes a part of the cost. So that cost gets translated to the user.
Right. No, but that's the thing. If everybody's being replaced, but you still need to be able to fund, you know, sustain the society, there has to be a way to balance it out. So then businesses will be like, yes, it may be a little bit cheaper to have automation, but like overall production would be faster and more efficient, but there'd still be a cost because of taxation. Anybody
This
else?
question, don't try to run away, that's so dirty. I mean, sorry. Dirty.